Hello, and welcome back to Zig's Math Lessons. Today, geometric sequences. And there's no point in continuing with the video if you don't have a pencil and a paper, a notebook, and a brain handy. Let's begin. Consider the sequence of numbers 2, 6, 18, 54. This sequence is not arithmetic because when you subtract backwards, you don't get the same number. So there's no common difference. But what happens if we divide backwards? We get 6 divided by 2 is 3. Recall, fractions are divisions. 18 divided by 6 is 3. 54 divided by 18 is 3. As a fraction is another word for a ratio, there is a common ratio between the terms of the sequence, and we call this common ratio R. The implication here is that to get to the next term, one multiplies by R. So t sub n plus 1, that's the next term, is t sub n, that's this term, times R. When there is a common ratio, the sequence is called geometric, as opposed to arithmetic. Consider another geometric sequence: 4, -2, 1, -1/2, a quarter. Take any term and divide by the previous term and you will always get -1/2. Try it for yourself. This shows that the common ratio can be negative, and it can be a fraction too. I just know my students are going to love that. The general sequence is, well, t sub 1 is still a, first term in the sequence. T sub 2, to get to the next term, multiply by r. So t sub 2 is ar. T sub 3 is ar times r, so ar squared. And so on. T sub 4 is ar squared times r, which is ar to the 3, and t sub 5 is ar to the 4. We could roll them out like this. Now, to get the general formula, we make an observation, just like we did before. We notice that this number is 1 less than this number. 3 is 1 less than 4. 4 is 1 less than 5. 2 is 1 less than 3. This r to the 1 is 1 less than 2. So it's always ar to the n minus 1. T sub n equals ar to the n minus 1, the general formula of a geometric sequence. Let's do some examples. Example: state the general formula and the 12th term. Solution: express the sequence using the general formula. To do that, we're going to need a, which is 4, and r, the result of dividing backwards. -12 divided by 4, or 36 divided by -12, is -3. The general case is t sub n equals ar to the n minus 1. So in this case, t sub n equals ar to the n minus 1. This is the general formula. And I would ask that you don't multiply 4 times -3 is -12, because this exponent takes priority over the multiplication. Now, to get the 12th term, we just take the formula we just figured out and plug in 12 for n. And on a calculator, my calculator tells me that this turns out to be -708,588, the 12th term in this geometric sequence. Another example: 243, 81, 9, 3. Solution: express the sequence using the general formula. To do this, we'll need a, which is 243, and r, the result of dividing backwards, the ratio, the common ratio r. So that's a third, because 3 over 9 is a third, 9 over 81 is a third, 81 over 243 is a third. Don't use decimals. There's our general formula, and plug those two in. And that is the general formula for this particular case. Please don't go 243 times a third. Again, this takes priority over the multiplication. So until you've used the exponent, you can't multiply yet. This is the general formula for this one. And for the 12th term, sub in 12. It'll be t sub 12 equals 243 1/3 to the 12 minus 1, which is 11. In order to simplify, we use knowledge and understanding which we learned in previous units from this course. For starters, 243 is 3 to the 5th, and 1/3 is 3 to the minus 1. And we've learned that in this configuration, those exponents multiply by each other, giving us. And we've learned that in this configuration, those exponents add to each other, giving us. And 3 to the minus 6 is 1 over 3 to the 6th. And it sure would be nice to know that 3 to the 6th is 729. A good student would know that. Don't use the decimal. Let's do another example. State the formula for the geometric sequence such that t sub 3 is 45 and t sub 7 is 3645. Solution: sub into the formula twice and solve by elimination. So, once again, there's the general formula, and this is code. It's saying that when the n here is 7, the term is 3645. So we can take the term, which is this entire thing, and turn it into the number 3645 when we turn the n right here into 7. Minus 1 is 6. Similarly, here, it's code for when I substitute 45 for the term in here, the n will be 3. Minus 1 is 2. So 45 equals AR to the 2. Draw a line and divide. This works because the two variables are multiplied by each other, so to eliminate one of them, we'll divide. Dividing on a calculator, dividing. Now the a's will cancel when we divide, and we'll subtract exponents. Taking fourth root both sides and turning it around, we got our r. r is 3. And we'll take that and plug it back in to the asterisk. So we get 45 equals a times 3 squared, which leads to 9a equals 45 and a equals 5. We have a, we have r, we have our formula. a r to the n minus 1. a r to the n minus 1. Once again, don't go 5 times 3 is 15. That would ruin it. A last example, find the number of terms in the sequence. So, we've got fractions, and we don't like decimals. Not in science, technology, engineering, and mathematics. In science, technology, engineering, and mathematics, decimals are, at best, second best. So we avoid them when possible. Solution: to find the number of terms in a sequence. Express the sequence using the general formula. Okay, well, I've got a. it's 36, and I got r because we'll divide backwards. 9 over 18, or 18 over 36. That's a half. There's our general formula. Plug the numbers in, and we have the formula for this particular geometric sequence. It's 36 times 1/2 to the n minus 1, and we're not even going to think about going 36 times a half because of this exponent up here. But this is t sub n. So we'll take this and plug it in to t sub n. Divide both sides by 36, and it becomes this. Now this may require some explanation. So let's think about this for a moment. This is true because we divided both sides by 36. This is true because we took this and divided both sides by 36. When you divide the right side by 36, the 36 simply cancels, and we're left with this. However, when we take the left side and divide by 36, let's follow the dominoes here. Left side, 9 over 128, divide by 36, which is 36 over 1. And when you divide by a fraction, you flip that fraction and multiply, and top times top over bottom times bottom yields that, which is what I put here. So when you take this, divide both sides by 36, that 36 turns up here. Now, simplifying further, the 9 and the 36 reduce, because 9 times 4 is 36. And when we look at this, we need to process it. And 1 over 128, it sure would be nice to know that 128 is 2 to the 7th. If you don't know it, 2 to the 5th is 32, so 2 to the 6th is 64, and 2 to the 7th is 128. So we are looking at 1 over 2 to the 7th times 1 over 2 to the 2. And in this configuration, we add those exponents, and we get keep the base and add the exponents. And now, using this logic, because the bases are the same, the exponents have to be equal. 9 must equal n minus 1. And now we've found it. N equals 10. And so there are 10 terms in the sequence. I'm Ziegelviet B. Stunk, and thanks for watching. If you liked it, leave a like, and if you like the content, please subscribe. Check back daily for updates and new videos, and I'll see you soon.